Yeah, we can hear you.
Cool.
Yes.
Cool.
So there's extension problems. There's extension problems for this thing. I don't think we need to worry about it. If we do the exam. Okay. All right. What's up?
Hey guys.
All right.
What do you want to go into, Jordan?
I'm not sure yet. I'm trying to make up my mind.
Do you want to know the setting in?
Yeah.
Okay. I have to take that one.
So how are you feeling about the test this week?
There's a few things I need to study pretty hard, but I studied a lot yesterday, so.
Okay. What are they? Because it might be the same thing.
There was a couple problems yesterday on the homework that. Let me look real quick. Had to do with like when you're doing like from rectangular to polar or polar to rectangular.
Okay. Let me grab my notes.
Yeah, let me look on.
I know which ones you're talking about. Rectangular coordinates. Rectangular. All right.
It was like.
I have one example right here if we want to do it.
Yeah, let's do that.
All right. So these are it's just like a foreign thing, right? Because we never talk about like rectangular points and polar points or whatever. But so here's the example I did on my homework. So there's the rectangular point, right? And so we have to go from rectangular to polar. So we have to go like R, because we go R equals the square root of x squared plus squared. So go here, we got -1 squared plus 2 squared. We need to come down. I'll just jump down to the final thing, right? Because you end up getting a square root of 5 in R equals, because they ask you to simplify that. R equals 2.2. Okay, so now we have to go to find the degree, the angle. And we take it. There we go. Okay, so here, we go like this. You take, so if there's two things. So if the x is greater than 0.
Yeah, this is the part that I couldn't figure out.
Okay, so here you go. So if x is greater than 0, you go, it equals tangent, the inverse of tangent.
Of y over x, right?
Yes, right? Okay, so you got y over x. If x is less than 0, you do this, which is almost all the problems I've seen, x is always less than 0 that we have to do. You go 180 minus, or is it plus? Yeah, it's plus.
It's plus.
It's plus. Plus tan, whatever, right? X over y. So for this problem, we have to do, y over x. We have to do the tangent of 2, inverse tangent of 2 over -1. So we get that, and you have then what we do is we take the thing we get. So from this problem we get -63.4, it looks like. And so all you do is you take that and you plus 180 to it, and you get 116.6 degrees. That make sense?
Yeah, that makes sense. It was just like the X greater
No,
than.
that thing, like, because it took me a little bit when I was doing my homework. I was like looking at the problem, and I had to go back and reread that twice. Because I was like, what is it like saying? Like, and so then I wrote down that problem, like the two equations you have to use, and it made a lot more sense after that.
There was another one. I can't remember what it was.
Do you get to do how taking like the polar points and getting them to rectangle?
Maybe that was that. Like,
'Cause that one's a little bit weirder.
it asks you like what quadrant on the unit circle it falls in.
Oh, let me see.
Do you remember doing one like that?
Yeah. Let me look.
I'm trying to.
Oh, I found the one for the find the angle between the two.
Okay,
I found the formula for it.
nice.
I'm looking, and I don't, because lesson 2 so this week's lesson 2 homework is all like polar crap. So I don't see any of those. The only one that is close to it is graph the polar equation, like graph the polar equation of theta equals the angle. So let me look on.
Yeah, it was right here. So go to on like the My Math Lab. It's number 5 for me. It says convert the polar coordinates to rectangular coordinates.
Okay. All right.
In the example, it says, like when you go through it, it says use a unit circle to evaluate cosine 30. So you just look up what.
Okay, so I'll look at mine because I've got a couple of different examples from polar to rectangle.
Okay.
So here we go. I'll do the first one that I have. So the polar coordinates we got are 1 and 4 degrees. Okay. So here we go. So what we do first is we have x. I write down the equations just so I never forget. X equals r cosine of the whatever the freaking degrees is, right? And y equals r sine of those degrees. So what we do, it's pretty. I mean, after you get it, it's pretty easy. You'll. Okay. So all we do is x equals r, which is this guy. So he's there, so we don't put anything in front of him. 4 degrees, and then x equals.
Y equals.
I mean, yeah, x. This one's because we're doing.
Okay.
I'll do that guy first because we have to have
Okay.
2 points.
Yeah, cool.
There you go, right? And so the first one, x equals 0.9976. So I just put x equals 1, and then y. We come over y equals sine of 4 degrees, and we get y equals. You got y equals 0.068, I believe. Oh, 698. 698, and we round it, you get y equals 0.1. So the points, then, if we had to put them in rectangle, would be 1.0 and 0.1.
Oh, that's all. That's the.
That's it. That's all I got to do.
All right. There was another one, but I can't find it. If I find it, I'll let you guys know.
So just yell at us. We'll do it. Because I have all of the homework problems written down.
Okay.
When you write down the problem, you just write down my work.
Yeah.
But that's fine.
Yeah, I just write down the problem, write down all the work that goes with it, do the next problem. So then when I'm studying later, I'm like, okay, this is how I do that problem. The only problem, okay, the only thing when I was studying, I cannot find on the homework, in examples, anything how to do number 2 of our extension problems last time. I cannot. I went online and looked how to do it, and I got this equation. I did it. I didn't get the same answers.
For the one that
Yeah, you know that stupid parallelogram that we were doing?
Oh yeah, the one with
Let
the
me
Joseph
drew
Smith.
it out. We started doing it.
So for this, you're just looking for these two sides?
Yeah, so well, you're looking for R pretty much, like the
Okay.
resultant force right here.
Yeah.
And so you do the equation. So there's like I was using the wrong equation, so I went back and used a different one. I still didn't get it. The equation's R equals A squared plus B squared minus 2. Oh crap! Sorry, it's A equals. It's A squared equals A squared plus B squared minus 2. But in this case, will be B squared and C squared. BC 2 would be a BC cosine theta, right? And so this angle, it says, the problem says you got one horse pulling at 200 pounds with force. You have another one pulling at 300 pounds of force. The angle between them is 65.
Okay.
So we put 65 on the end here because that's the angle between them. We do all the math and get it, and I got like 285, and the answer was like 425 point something. I was like, how the freak did you get it? So then I started looking, maybe like I had to put something in for like the angles and everything, but I couldn't find anything. Because like this, like I think it's what it's saying is like you want to like find this. He's trying to say like find this angle, you find this angle, but he only gives us the one angle. And so you're like, okay, but he gives us a side and a side. So that's why I was like, I just don't freaking know. And like all of the ones that we do are like this one or R equals A squared plus B squared.
Okay.
And so I just couldn't like I looked it up online like to find a problem like that. I just typed in like resultant force equations, and the only ones that came up are those two. And so I used both of them, and I couldn't get the same answer. So teacher he got for this one.
The only way I can think of this probably took a really long time.
Yeah, that's what I was thinking too. Maybe it'll take forever, but like
I mean, because you could draw a line here.
yeah, and
this
then
a
make two triangles.
Yeah. And
So
then,
you would draw it here, and you'd have this side, and you'd have that angle. So then you'd have to find this side, which I mean wouldn't be that bad. You just find it and go through and. But like yeah, we're looking for R. We're looking for the resultant force.
So then you could get this angle, and then you could break this up into a triangle.
Because this
angle.
triangle is congruent to this one.
Is it?
Yeah, that's what he says. They said they're congruent. So I'm like, okay, well then this triangle is the same as this triangle.
Okay.
Yeah. Like,
So what I have to do is find once we found this triangle, we just have to find the height. And
yeah,
then we just double that.
yeah. And so that's why I'm like looking at it. I was like, so that's what I did. I doubled my answer,
Didn't work.
and I didn't get the same one. So I'm like, fetch, how is it? I just couldn't find it at all. But the equations, there's like tons of. I've learned like really new when we went in there and did the equations. Like that was a big help because on the homework, the last like 5 problems are all doing equations.
Yeah.
And so I was like, oh yeah.
Cruising through.
Yeah. All right. So, Jordan, have you looked at the review?
The exam review.
Yeah.
Yes.
Was there anything on there you wanted to go over?
Let me look at it real quick.
We might just want to go over one graph because I
For sure.
graph, like this one.
Yeah. Okay.
We just go over the graph maybe once.
Sounds good.
Because like I know how to do it now, but like you remember you weren't there for that quiz we took. But we took like they gave us a graph and we had to write the equation for it. And so I figured out how to do it and I think I got the right answer. But it was just crappy. I was like, because the only thing for me on the review that I was like kind of looking at, I was like, I don't know if I could know how to do that or whatever, was just the graphs. Because the other stuff, like this stuff we've done this week, so it's not that bad.
Yeah, I remember like the graphing section,
The graphing is like the only thing for me that,
the one that I struggled with. And like section 5.3 and 5.4, I think.
yeah, that's pretty much it too. Hopefully we don't have too many problems like this one. But that's a triangle, so I'm like, oh, triangles are easy.
Yeah.
I'm hoping he doesn't give us a word problem in this section. Like that one.
That would be awful.
All right, we could go over, let's just go over the graphs and we'll take our quiz.
Oh, we have a quiz too this
Yeah,
one?
we do.
What?
I know.
Just take a look at this quiz situation.
Yeah, you wanted to look at the quiz. Maybe we could just do the quiz instead. Maybe it has a graph on it. I think so.
I think the quiz will just cover like this week's stuff on week 4, right?
Yeah,
3 weeks.
I know. We only have 4. Like we have 2 on week 5, 2 on week 6. We don't have any week 7.
Really?
It's all tests.
Oh, babe.
Which one are we doing?
Got
We're gonna go
distracted.
to the quiz and look at the quiz, and then we'll yeah, right there. Oh, that's week 6. What? Yeah, that's it.
Oh.
Why don't we
Sorry,
Oh. Oh, so it's right there. Yes.
okay.
Week
group
4. I was
quiz.
like, dang, week 6 quiz. What the heck? Why did you put that on here? So yeah, it's not too bad. The first one's not great.
No calculate want to swim from one side of the river to the other. It may help to draw a picture. Will do, teacher.
So the only one I was looking at that I don't like is number 1. But 2, 3, and 4 are fine.
Okay. River. I'm going across at 3 miles per hour. The river's going this way at 6.2 miles per hour. So my resultant should be right there.
Yep, exactly. Yep, we have to find the resultant speed and direction.
So we're going 3 miles per hour west.
Yep,
The river is going
6.2 miles an hour in the north direction.
north. So we're going northwest.
Mm-hmm. So I can find the angle, like the angle, direction angle. That one's like, see, I'll show you the equation for it. It's this guy.
Is the speed the same as magnitude or no? Like when they ask that?
That's what V is magnitude. Like, so V into absolute value is a magnitude.
Yeah, but is that what they're asking for in this question? Like when it says, what is your resultant speed and direction?
I don't know, but I would guess, Nate, but
Like, is it just, because I don't know how else you would do it.
I don't either.
Yeah.
I know how to get the angle. It's a really sucky long equation, but we can get it.
I don't think we need, isn't there an equation to just find this line?
Yeah, that's find the smallest possible angle between these stupid 2 guys. It's this, because I wouldn't watch the video that he did, and it showed the equation. So I was like, I've never done that. So I went through my notes and I found, okay, I was like, I did it one time. This is it. He has a video. Let me pull up the video. Right. It's in like lesson week 1 preparation, lesson 1 video on under resources. Video on angles. It was like 80. So here it is. Vectors, example part 1, dot product and angle between vectors. That's essentially what that is.
Yeah.
Right? Angle between vectors. So you pull up this stupid thing. And here's his video. Okay, so here it is. That's the equation.
Seems like that's way more complicated than it should be.
So here it is. So I did this one, right? We have two vectors, a squared plus b squared. So you do 5 plus 1 for a, right?
Mm-hmm.
So you do an a, you get that one. You do b, get that one. You stick it in this formula over here, down here, because we already got 21, the product above. That's up on top. So we have the magnitude of each of them. And then we put it in, we have to do this. And get that. And your calculator doesn't like this problem.
Okay.
So that's how we do it. So I know how to do that, but I don't know.
Thing is that for this one though, we just have the one coordinates, 3 and 6, 2, whereas this one we had 2.
Yeah, and so that's why I'm sitting here. So I'm thinking we just find the direction angle between the two. So we find the magnitude of the point, right? We have that one and that one.
Yeah.
So we find that, the magnitude, that's what I'm guessing, and find the direction angle.
Josh pencil walks out.
Yeah, I'm out. All right. So I guess we could do that. So do you want to do, Jordan, do you want to go over the graph or do you want to just do the quiz?
I'm cool with just doing the quiz, but whatever you guys
Okay.
want to do.
Sounds good.
I mean, why don't we do the quiz, and if we have like time left
We'll
over,
do
then
the
we
graph,
could do the
okay.
graph too.
Sounds good.
I think it'd be a good review.
Okay. All right, David, do you know this angle stuff better than we do? So.
I don't know if I know this angle stuff better than anybody.
Okay, so we'll try to do it and see if it makes any sense to us.
Yeah.
Okay, so we'll do it on the board. Let's give you the
equation.
Yeah, I'll give you the equation. Okay, so we're doing, so the point is 3,
6.2, sorry.
3 and 6.2. So we're really trying to look for B and direction angle. That's what we're looking for. Is that what we're looking? That's what I'm getting from? But what do you think we're looking for? You tell me. Like I'm open. What do you think, Jordan?
I think it's asking for magnitude when it says resultant speed. But I don't know.
I don't either. That's my point. And
Let me find a problem like this on the homework, 'cause I know we did a few.
Because I was like, I have a resultant. I think it was a resultant force one. Find the magnitude and direction angle of the resultant right here. But it's the same exact thing.
So like, is the 3 miles per hour and the 6.2, are those like our coordinate points?
That's what we are guessing. That's what we did.
That's
Yeah.
what we need to find magnitude and direction.
Yeah, so all you do is you find the magnitude, right? And then we would find the direction angle, and that should give us the direction. Because the direction, like we drew a picture.
Yeah.
So we see the direction angle is headed down like to quadrant 4.
Uh-huh.
So you know the direction angle is going to be bigger than 270. Down the first homework.
Pretty sure.
Oh, I didn't write any of those down because I just did them.
Yeah. Magnitude.
What are we doing that? Because I have that problem written down.
This is what I think we're doing.
Okay.
Something more like this.
But then we only have. So
No,
we're
this is
looking,
not what we're doing.
yeah, I was like, are we looking for because I was like, that one, that's the horizontal and vertical magnitude.
Yeah, that's not what we're doing. Sorry.
I think that's what we're
This is
doing.
what we're doing.
Okay, perfect. Okay, all right, I think we got this. Okay, so we got we got the equation we're using. We could label it X or Y. I'll just label it A and B. That's A. That's B. R equals A squared plus B squared. Or
So yeah, you're right down the right track. Yeah.
no,
you're going that way.
we'll just do this guy to keep it all same. B equals that. Okay, so we put it in. We got square root of 3 squared plus 6.2.
That's 47.44, I think.
40s all under square root. Under the square root.
Yeah.
Okay, so we got 47.44. That's our. So let's just put like square root it and see what we get.
You get 6.9 rounded, 6.9.
Okay, 6.9. We'll keep that. Okay, so that's our magnitude, 6.9. I'll have to write this all down, but it's okay.
Yeah. So we got the sine of theta equals b over v.
Okay, so we got.
So that's just point.
So it goes, for this guy, we got sine theta equals
B over v.
B over V.
Yeah.
B,
It's the absolute value of v, but
so that guy,
yeah.
6.9. So B equals,
Is our 6.2 right?
yep, 6.2. That, what is, and so what we're going to do is because we don't have that, so we're looking for, we have to take that off the other side. So we're end up getting B equals sine -1, right? So inverse.
Inverse sine, yeah.
6.2 over 6.9. What does that give?
64.179.
64.179.
Yeah.
So we got 64.179. I think we've minus that from.
So in my example problem, it says, this is the part that I don't get. It says, notice that the vector, and then it gives the points, terminates in quadrant 2. Therefore, its direction angle is 180 minus whatever.
Yeah, so this one terminates in quadrant 4.
How do I know where it terminates? Like, where do they get that from?
So we drew it. So like it tells us in the picture, like, well, I'll draw it up here exactly how we drew it. So we have this thing like this, right? So it gives us, this is like west, right? And then we put this as north.
You just do like the top north. I did it on mine backwards, but how are you
Okay.
gonna do it, man?
So this is west.
Yeah.
That was north, okay? So we know we're going this way at 3 miles per hour, right?
Uh-huh.
Okay? The water is going this way at 6.2 miles per hour. So the resultant we know is right here.
But is west the other way? Or how did you?
Yeah, it would be. This is east. So it really would be,
But does that matter?
yeah,
Because then that's quadrant 2, right?
yep. So it goes this way 3 miles per hour, which would make it right there. So we know that we got the magnitude, it's 6.9, okay? And so the angle then we would take, we got this, we take 180 minus, it's 180 minus 64.179. What does that give us?
$115.82.
So we got 115.82 degrees. Is that angle in quadrant 2?
115. I don't have my unit circle in front of me.
115. Yeah. So then really what we're doing here is we're getting the measurement.
Yeah, 115 is in quadrant 2.
Remember that one problem we had to do where we had this stupid thing on the angle of the triangle we had to do? and we had to come around like that. It was like two, like.
Yeah, I remember that.
Okay, so I guess I'll write this problem down because we have to do all our work and show it. And I have a scanner at my house, so
Oh, nice.
I just scan it replaces it. Awesome. Okay. So if that was that the problem, Jordan, that you were talking about? Was one like that? Where is he? Here he is.
Sorry, I don't know what happened.
You're all good. I was gonna say, so was that the problem that you were talking about?
Yeah, the quadrant thing. I was confused.
Yeah.
with that.
So
But I think-
usually they give you usually on our homework they gave us a picture,
Mhm.
Yeah.
so we would just be able to see which quadrant was it and like take you could minus it, but like it really just depends on where that guy is.
So,
So-
like, say it ended in quadrant 3, what would you do? You
You
don't
take 180 plus that.
you plus it.
Yeah, you don't take 270 minus it. You would take 180 plus it, and that'd give you the angle. And the same thing with here. You don't take 360 and minus it. You take 270 and plus it.
In quadrant 1.
Yeah, because if it's for quadrant 4. If it was quadrant 1, you would take 0 and plus it.
Okay.
Like there's not very many times that you use 360 and you minus it. I think on the homework there was one I did.
Those are the ones I kept missing, and I couldn't figure out why.
Yeah, let me grab it. I know we had one that
I was
we.
doing everything right except that.
Let me see. I don't know where crap it is. Though. Yeah, right there. So we had a negative 71.6 angle. It's like on question 12 of lesson 1. And so how we know is if we got the negative 71. So you know which quadrant it is in, right? You know which quadrants it's in. So like pretty much because let me see. No, it wouldn't be the same. Why the heck did we use it? I can't remember. Let me go look it up real quick.
What was the question again?
It's this one. It was just why because this one's in quadrant 2. I mean this one was in quadrant 3 and it was negative, so we minused it. But then this one is in quadrant 4. We took 360 and minus it. Usually you take 270 and plus it.
Okay.
But see, that's where I was like, I said, oh, there's one that I did. I know I did.
Mhm.
That we took to 360 and minus it. And then I was like, oh, they're not the same when you do it. Okay, so it was on lesson 4, lead vectors, and it's number 12. That guy right there. I also did this homework on Monday, so
Yeah.
it's been a while since I've looked. Okay, let's do example. Okay. Simplified to the inverse. Okay. Looks at the vector quadrant. Okay, so it's like this. Draw this stupid. So this is how we know, because like this one didn't give me a picture. This is how we know. You have to find the rectangle, whatever, right? So he gives us the point 362. So we know. See, this is where I'm thrown off. If we went 3, 1, 2, 3, and 6.2. So 1, 2, 3, 4, 5, 6. So it's like right there. So we go over 3. Up. It's right here. That would be our. So we know this is quad 1, 2, 3, 4. Right. So that's why I'm like almost debating this is west.
Yeah.
Unless
Positive.
this would be -3 then to be in quad 2.
Yeah. But yeah. So we were right with quadrant 1.
Yeah. So what we would do is we would have done. Yeah. See, well, that's because that's where I'm looking at is what are we like that point is in this quadrant, not that quadrant.
I mean, also, we don't necessarily know they went 3 miles or 6.2 miles, so they're going 3 miles per hour,
Yeah.
6.2 miles per hour. So,
It doesn't give us the angle between them, does it?
no,
Yeah. See, that's where I'm like.
that's what I was thinking about too. Okay, yeah.
Oh, could this be like? We didn't do it this week though, so much I don't know why I did the quiz. But that would be almost exactly like.
How does he grade the quizzes? Like,
I don't know. We haven't had any of them graded yet.
I know he doesn't. I don't have hardly anything graded either.
So it was like this one. I remember that problem. But see, this one gives us the degrees and everything, so we can make a triangle and do it. Where this one doesn't. This one is the only thing that makes sense for this problem is this. Because resultant is just u plus v, isn't it? U times v or u plus v.
Sounds right.
See, because if you look at this, it's u plus v. So if we did the resultant of this vector and this vector,
That actually makes a lot of sense.
it would be, because the vector is, so this vector right here, right, is 0, 6.2. And this vector would be 3, 0. Wouldn't it? Because we don't have like a thing to go up off of, like we're out. We just know this guy's here, 3 miles. He just went 3 miles an hour west, so he'd be on the x-axis.
We would be on the x-axis. We don't know if he's at point 3.
Yeah, we don't know where the heck he's at, but we just know that, like, let's just say that that's it, right? And then let's say this guy, we just know he went 6.2 miles per hour north. So to find this guy, we plus those. If you plus them, you would get our vector, right? Because we would say u plus v. So let's say that's u, that's v. You know, they're the same. You did that. 3 plus 0 is 3. 0 plus 6.2 is that. And so if we did that, we'd go 3 here, 1, 2, 3, or this way, whatever. 1, 2, 3, up 6.2. Our vector, our point would be sitting right there.
I see you. Could it be even more simple than that? That it would be literally just
9.2.
6.2, yeah.
That's
plus
exactly what I was thinking. That's what exactly what I was
I
thinking.
know we know it's
9.
northwest.
Yeah.
I think we're just overthinking it. Because that would make sense. We know he's doing 9.2 miles per hour.
See-
He's swimming at 3, we're taking a 6.
See, and that's what kills me is like, because I was like, well, resultant, we know the resultant is U plus V. So like, we're finding all this crap, but like, 3 plus that is 9.2 miles per hour. North, west.
Yeah, that's what it is. That's the answer. We're overthinking
Okay. Well, let's do all of this.
it.
I'm just gonna go here, draw a resultant, and say it's 9.2.
Does that make sense, Jordan?
Yeah, so you're saying one was on the x-axis, the other was on the y, right?
No, forget about that.
We're overthinking this
We were
situation.
just trying to be mathematicians, and we're not.
It's the river's taking him 6 miles per hour. One way he's swimming 3 miles per hour.
Against it, pretty much.
Yeah,
Like sideways.
sideways with it. So he's going a total of 9.2 miles per hour. And we know he's going northwest. Or yeah, northwest, right? Yeah, northwest.
Yeah. So, because
Just
like
add them
that's
together.
because we're on last week's extension problems. We have a problem number 1 is just like this. So we have a graph, and we have a point like from here, like a vector going that, and a vector going there,
Oh, yeah.
and then it says find the resultant. Okay, so it's find resultant. The resultant is right here, right in the middle, right?
Yeah.
So to find that resultant, you go, let's say that's U, that's V. Resultant equals U plus V.
So you literally just take 6.2.
Literally, you take, so this is 3, that's 6.2, but ours is like this way and this way at 90-degree angles pretty much. And you would take 3 plus 6.2 equals 9.2. And like, let's say this is north, that's west, because Celsius is heading west. 9.2 miles per hour northwest.
Yeah, that makes perfect sense to me.
Yep.
Cool.
If we're wrong, I really don't think it matters. So,
So the next one, write the equivalent rectangle equation for the polar equation r equals 10, 3 cosine theta, 7 cosine theta.
because it doesn't ask us in that, it says direction. It doesn't say direction angle.
No, yeah, it just says direction.
So yeah, this one.
Cool.
Number 2 is what does it do to write a equation from polar equation? So write a rectangle equation. Okay, I got it.
Exactly.
We got this. We got this. So I have one. Where was it? I had one that was exactly like this. And I can't find it. Oh, right here. These are all of them. Okay. So write rectangle equation from r equals 6 cosine. So this one is. So let me build this up here.
I can read it to you.
Okay, so the equation, give you the equation.
R equals 10 over 3 sine theta
3 sine theta.
minus 7 cosine theta.
Okay. All in parentheses, fine. Okay, so we got this one. I don't like that one so. This one looks better. Okay, this one looks a lot better. So what we're gonna do, so first off, we're gonna times, we gotta find out like the equation that we're looking for, right?
Yeah, so you gotta find like,
The equation that we're gonna look for, because it's it says, write a rectangle equation. Am I correct?
Yeah, right, yeah.
Okay, so here we go. Okay, now it's making more sense. So x equals r cosine theta, right?
Yeah,
Y equals r sine theta.
exactly.
So here we go. We have to have an x value and a y value, and this is the problem we did over there.
With them, yeah.
It just sucks because it's like 20 steps long. Okay, so first thing we're gonna do off of this problem, see, I haven't had one exactly like this, but we're gonna take the denominator and times it to the other side.
Yeah.
So we got r times 3 sine theta minus 7 cosine theta equals 10. Okay? So I think that's what we're doing first. Then what we're gonna do is we gotta get it all onto one side.
So would we distribute first? We multiply r 3r cosine
Yes.
theta minus.
It's like, I think, yeah. Yes, we do. We distribute, that's the next step. You're exactly right.
Gotcha.
So we got 3r sine, right?
Yeah,
3r, yeah.
whatever, yeah.
3r sine theta minus 7r cosine equals 10. You got that ugly problem. Okay,
Awful.
so then what we do on this side, yeah, see, I have it all written down, and I think it's making sense. But see, like, to this side, we take the plus r cosine to that side, plus r sine to that side, right?
Okay.
See, this problem sucks. Because I haven't had one with both in the denominator. Hey, do you remember the problem that we did?
With the tutor?
Yeah. So we still only had 1 on the bottom. No, we have 2 right here. But that's going from that one to that one. So maybe we can do it backwards. I think we're doing it the right way. I think we're doing it the right way. I think we end up, yeah, because if I'm looking at this one,
So wouldn't r cosine theta just become x? But
okay,
we would do 3x.
okay, it's like this. This is stupid. I hate this. Okay, so because looking at this problem, because this one has cosine and everything, so we know that, so if 2 cosine is on the bottom, like 7 cosine, we know 7x is in our problem. Okay?
Yeah.
So sine, what's sines?
Y.
Is y, it's 3.
Mhm.
So we know that there's going to be 3y in our problem. We know there's 3y, and then we know there's freaking 10. Okay? And if I'm doing it correctly, it's going to be something like,
It'd be like 7x plus 10 and then divide both sides by the 3 equals 7 over 3x plus 10 over 3.
something
what I
like,
think.
or like the other whole thing over 3.
Yeah.
So that's what I'm looking at too, because like I'm looking at this one, like this problem. So if you just work backwards,
Mhm.
-1, so the -1 is on top. He's on top, so we have to have plus 10. Get that? So like exactly how you said,
Okay.
how you put, where was it? Right there, plus 10, perfect, okay? So we know we have that. So the other thing I'm looking at is yes, y equals, because y is 1, in this problem.
Yeah.
So there's nothing in front of sine. So you're exactly right. So it would be this. It would be 3y equals 7x plus 10. So the way we can check our problem, I guess, I hate this, is we can go backwards. So if we did it backwards, we would do first, let me see if I can find one. You substitute the values in. Right, so y would be r sine is equals r cosine. So to get that
Our
out,
cosine would have a 7 on it.
so then we times it by 3, we get 3r sine equals 7r cosine plus 10. Okay, so we want to get that on the side. So we times it by, we minus this to each side.
Yeah.
So we get 3r sine equals 7, oops,
Third minus.
minus 7r cosine equals 10, right? So we can factor out an r. With r, so 3 sine minus
That's it?
7 cosine. Yeah, I think we got it. Right? Equals 10. And then to get rid of this, we divide that,
Mhm.
and that's all over it. Got it. So
Yeah.
that's the equation, right? There. So,
You guys end up with?
so did you follow any of that I just said?
So I followed down to like where we got down to like 3r sine theta minus 7r cosine theta equals 10.
Okay, so me and David just skipped all of our equation steps because we were like, I don't want to do it. But more, it's like it's easy to, if you understand the equations, you don't have to go through all these steps to find it.
Okay, what did you guys
do?
said then?
Because we know with this stuff, because we know this right here, x equals r cosine theta, right? So r equals this. So this guy is our x value. This guy is our y value. And he, because he's a positive 10, has to be a plus 10. If it was a negative 10, it'd be a minus 10. So we just skipped all of our steps and said, okay, look, 7 is our x value, 3 sine, right, is our y value. And our equations that we'd always look for is y equals this rectangular form, right? So what we did was we said, okay, we got 3y equals 7, which would be 7x, that's our x value, plus 10. But we can't have a 3y over here. Divide 3, and it gives us y equals 7x plus 10 over 3. So to check our answer, this when you have an equation like this, it's so much easier to put it in this form. Like it just is, because it just makes more sense. And like this one's like going backwards, or this one's going forwards. So what we did was we just took it and we just substituted the values in and redid the problem to see if we got this problem, and we did.
Okay, there was one like that on the homework, right, where you just substituted it.
Kind of. There's one almost. There's kind of like it. The only difference is we don't have 2 values in the bottom.
Yeah.
But the last time David and I went to the math tutor, and there was a problem that was similar to it, where it had 2 in the bottom, and he showed it, like he kind of went over it, and me and David figured out how to do it. So like that's why we were just like, oh yeah, throw it out together. So if we had to go through this problem the whole way, we'd have it like this, okay? We'd have this problem just like this, so we would plus 7r cosine over here, so we'd end up with 3r sine theta equals 7r cosine theta plus 10. So then what we would do is we would just take this value, this thing, and substitute it. 3y equals 7x plus 10, divide by 3, and we come up with the answer. That's it. Okay, all right. Does that make sense?
Yeah, that's a lot easier than how we were doing it to start.
Yeah, like, so all me and David were doing was we were just using our mathematician brains and skipping all of these steps. But I'll hurry and write it down. You can start doing the next problem.
Okay. So on this next problem, basically I think we're just going.
You can erase the middle thing. I'll just write that down. Then you can I'll just erase it.
We're gonna see my face for a second here while I'm copying this problem down.
No problem, man.
Cool. Can you see it okay? We got our equation here. We're going from polar to rectangular, I believe. So we just want to basically take the square root of everything. So it'll be x plus y. No, we can't do that. Yeah. Can we just take the square root of all this and then just get x plus y equals 3 over y plus x? Is that okay?
I think. Did we have one that we did like this?
I don't know.
I don't know if we did. I think we might have. I don't know.
Do you think that's okay, Jordan?
What's that?
Saying, so we've got our, for the next problem, x squared plus y squared equals 9,
Yes.
x, y over x.
Yeah,
squared.
because look at this problem. We have x squared plus y squared equals 9, and the answer is 3.
Yeah,
So
okay,
he square rooted that whole thing. 9,
Gotcha.
9 square root is 3.
cool,
So yeah, square root.
sweet. So again, that's square root, so we said x plus y equals y over x. So we can say multiply both sides times x. We get x squared plus y equals 3. We can say y equals 3 minus x squared. So we got that broken down. Now I just have to figure out what it's equivalent to in polar coordinates. I could be going the complete wrong direction with this problem. I'm not sure. Do we have to memorize all of these equations that we went over last time?
Yep.
Holy cow. I'm behind on that then.
Yep. That's why when I studied yesterday, I tried to go over how to do all of them.
So then, from my broken down formula, we can say y equals r sine of theta equals 3 minus r cosine theta squared.
Man, look at David.
Don't know
No, it's okay.
what's the best way to do it.
It's okay. Well, all I'll do is we'll just go back and check it. Do the reverse formula. So here it is.
Okay, so we want to get things in terms of r equals.
Yeah.
So this is where things get tricky because we have to square this. This way I'm not sure that this is the best way. So it would be
So we have to square root that.
no, I just have to square it.
Oh, square the whole. You're right, because we have to get r equals.
That whatever, yeah.
Because what's the r equals formula? The r equals formula is. Well, we just have to get r equals.
Yeah, that's all I have to do.
So we would try to get.
And we can subtract that from both sides. So we got both sides. R sine of theta minus
The r.
plus r
Cosine, exactly,
theta
squared equals 3.
3.
So now we just factor out our r.
Can we just factor out the r though since it's squared?
No, I'm almost have to get the square out of there. One, this problem sucks.
So if we go back up to, let's say, we could say r cosine theta plus r sine theta equals 3, and then we know that
Sine over
x
sine.
over y equals tangent of theta.
Yes, I think you're right. I think you're right.
Tangent of theta.
Yep, look at this one. Given x and y, you got r squared equals x squared plus y squared. Then you square root that, tangent theta equals y.
Cool. Okay. So,
You're right. No,
Got
you're exactly right, okay?
so we factor out the
I
r.
factor the r out.
The tangent of theta. So we just divide both sides by that.
Yep. So it's 3 tan over cosine theta plus sine theta. I think that's it.
Yeah, that looks right.
Because then if we do it, let's like redo the problem. We would times each side by it.
Yeah.
Okay, so we'd go exactly back to this.
Uh-huh.
Okay. We distribute the r, we get this. Okay.
Uh-huh.
So then what we would do for tangent, we would know that it's really just this.
Uh-huh.
Because like we would times, because if we had it like, okay, so we had r cosine plus r sine equals 3 tangent. Really all that's saying is we had sine over cosine.
Yeah.
That's all it's saying.
Uh-huh.
So if we redid the problem, we would have exactly what we had before. We would have, because this is really, what we're saying is this is x, this is y. And if we took the tangent out, we would have y over x. We would have had this over this. Didn't we?
Yeah. The only thing I'm concerned about still is just this situation right here. Because it would be no, never mind. Never mind. I'm crazy. Okay, yeah, because you're exactly right. That's
Yeah,
good.
because we'd have that, right?
Yeah.
And so then we'd have sine over cosine over here. But then what we would do is exactly what we had, right? Like you'd have 3, whatever. If we squared it, it'd be that. And then we would square this side, and we get that.
Gotcha.
If we squared the whole thing,
Yeah.
we would get this. We would get that problem.
Yeah. That makes sense. Cool.
I think that's
the
it.
answer.
That makes sense, Jordan?
Yeah, it made sense until like the very end.
So at the very end. Okay.
Just briefly, where did you guys go from y equals 3 minus x squared?
Y.
Equal this part, right?
Equals 3.
Okay, so
This is
see all of this right here?
Yeah.
Ignore it. Erase it from your
Yeah.
mind.
So right there, perfect. Now David will take you step by step.
So that way would have worked out, but I'm not really sure. My algebra was not good enough to do the squaring. So what's easier is this. So we have x plus y equals 3 y over x. So we know the identity for this one. X is the same as saying r cosine theta plus y is the same as saying r sine theta. Does that make sense?
Yeah, that makes sense.
Just to memorize. It's the sheet that Jordan went over with us last time that he wrote up on the board. Hopefully you're able to copy that down. And then we know that y over x, we have another identity for this one. That is the same thing as tangent of theta. Does that make sense?
Okay. So y over x is tangent of theta?
Correct.
Yeah, because it's just sine, well, tangent sine over cosine,
Yeah.
or opposite over adjacent.
So you with me?
That makes. Yep.
Okay. So what we want is we want r by itself. So we have to factor on r here. Since r is the same in both of these, we can do that. So we have r times the quantity cosine of theta plus sine of theta equals 3 tangent of theta. Okay?
Mm-hmm.
So all I did is just factor out the r from this one, from these two to here. So we want to get r by itself. So I divided both sides by the cosine of theta plus the sine of theta. Cancel that on this side. Divide this side by cosine of theta plus sine of theta, and we get r equals 3 times the tangent of theta over the cosine of theta plus sine of theta.
Okay, that makes a lot of sense.
Cool. These, honestly, these are super easy.
It's just sucky.
memorize.
Yeah, you have to almost like be able to know it's almost like doing algebra
Yeah.
in trigonometry. So it's like, if those were numbers, if tangent, cosine, and sine were numbers, it would make more sense to our brain, but it's a word.
Yeah.
So we're like, we can't divide words,
Doesn't work.
but it actually represents something. So it's like, oh, that sucks.
Cool. So we just have one more problem now. So the graph the polar coordinate for
Okay.
4 pi over 3.
We got this.
Oh yeah.
We got this.
An ordered pair in polar coordinates. Name a single point. However, the coordinate is not unique. Name 2 other polar coordinates that are located on the same place for 4 pi over 3.
Okay, am I good to erase all this? I have it written.
Go for it. Yeah. As long as you got it written down.
Yep, I have it written down. Okay, so here we go. So we know this stupid polar coordinate. I'm gonna draw this guy.
I'm gonna drink water real quick.
Go for it. And the polar coordinate is 4 pi thirds. Okay. Okay, so oops. That's really ugly, but it'll work. So, Jordan, do you know how to do this one?
I kind of remember.
Yeah, you just
It's
you,
like
you tell me, and I'll start doing it.
All right, so it's 4 pi over 3. So I honestly can't remember.
Okay, you're good.
It's 1 point, so you go 4.
Yes. So you almost ignore, if I so you almost ignore which direction you're going to go, because 4 pi over 3 is the direction that you're plotting your point. You see that? Like, because our natural inclination is say, oh, look, that's a positive 4, so we have to go 4 on the x-axis, right? But where's 4 pi 3 on your unit circle? What angle is that?
The third quadrant 3.
It's in quadrant 3. So how the heck could we plot a quadrant of 4 over here if the angle's over here?
Okay, so you just go 4 lines out.
Let's go 4. It doesn't matter if it's positive or negative. It's just 4 to that side. 1, 2, 3, 4. We know that quadrant 4 pi 3 is like right there, right? So, but there's also so we have to name 2 other points that are at that point. So if I remember correctly, we have one just like this on one of our little, yeah, so right here. So for number 3, like, okay, for this stupid one, we have 1 negative pi half, right? So like 1 negative pi half is that one. That's made so much sense to me before.
Would be because it's just.
Oh, because pi half's 90. That's why. That is why. Okay, so like this one, right? We would say 1 negative pi half. And so negative pi half is 90 degrees, so it's on the y-axis.
Okay.
You have to go 1. Put it on the y-axis. Because it's negative.
lost me with this.
Okay, so
Are
here
you
we
doing it
go.
for your problem here or for this problem?
No, I'm just showing, I'm just like, because like this one problem had 2 or 3 points in the same point.
Okay.
So I'm trying to see which formula we could get to do that one. So like this guy, right, pi halves is right here on this line.
Yeah.
This is negative pi halves.
Mm-hmm.
So if I had to, if our equation was, our point was 1 negative pi halves, it's right here.
Okay.
Okay, so here's the other stupid thing. So here, the next point that's the same exact point is a negative 1, 450 degrees. So we go down right here, we have 360 plus 4. So to get to here, we have to plus, you go by, what's it freaking called? 360 to get around it.
What's that point? 450?
450 degrees.
So we're going
Negative
basically-
90, that's right. Okay, so at 360,
Wait, would it be negative 90 or would it be positive 90?
well, if we went positive 90 from 360, it'd be here.
Yeah, because we're going, is this positive or negative 450? So it'd be 360 and then plus 90, so you're right there with it.
Yeah, and so he has it positive right there
The teacher does.
because it's negative 1.
Oh, yeah, that makes sense. I'm with you.
Okay, so that's all I have to do is we have to find,
Oh, that's super easy.
yeah, so we have to find 2 other points that hit that point. So we use that one, right?
So wouldn't it be 8 pi thirds, and then wouldn't it be
Because 8 pi thirds is,
12 pi thirds?
I think so.
Yeah. Wait. So, sorry, this would be 7 pi thirds.
So 7 pi
Yeah.
thirds, yeah,
So, no, I'm
it'd
wrong.
be 8
It'd be 8.
because you have to go around once to hit it. So what's 8 pi thirds degree, right, is? So we could say the same thing, like, what if we said, because what's 240 twice? Is 480, right? So if we went around 480 degrees, so if we said 480 as 1. So here we go, 360.
This should be 9. Final answer.
Okay, so like, let's say we went, so this guy's at 240 degrees, right? So if we said, this one sucks, he should be at -4, he should be right here. So if we said -4 at 480 degrees. Let's see, because like, you have 360, he's 240. Right? So
Yeah.
360. So if we went 90 from 360, that would be 450. If we went 90 more from 450, that would be, no, you're good. What's it, 450 plus 90 is 540. 540 to 80s plus 60. 540 would be, plus 180, right? So we had
Final answer.
that guy.
This is my final answer.
Well, so what we could do is we could throw. We could throw a 1 in like he did and put a degree. Like this one, we could just do -4 and put a degree as that. And you get it. Because
You mean just from right now, -4?
-4.
For this.
Because we're gonna have to go down 4. Or we could just go over 4, I guess. And go to the degree.
Yeah.
It's like, so here it is. So that's what I'm trying to think. So 360 plus 90 is 450 plus 90 is 540, right? And so from 180 to 4 pi halves is 60 degrees.
I mean,
So that's
All we need to do is just
600.
we can just convert this to degrees, just this number, this to degrees, and this to degrees. And this should be 306. This should be this plus
That should be 240.
And this should be this plus 360.
Yeah, because it goes around once.
Yeah.
Yeah. Okay,
That's
let's do that.
actually-
Let's already do that.
So, get the formula. Equals 180. So we have 4 5/3.
I over 180, right?
Can you do that in your calculator?
Yeah. 4 pi over 30. Is it times 180 over pi, right?
Yeah. So you multiply.
Times 180.
I mean, really, the
divided by
pi's
pi.
will cancel out. So you could just take 4.
That's 240. That equals 240.
40. So then, if you could add that to 360.
So plus 360. So let's do that. So it should be 600, 2 pi, and 10 pi. 10 pi divided by 3 times 180 divided by pi. 600. Yep, that's right. And then negative 2 pi halves.
Yeah.
I mean thirds.
Uh-huh.
So then negative 2 pi divided by 3 times 180 divided by pi equals negative 120, which would be 240. Got it. Okay, that sounds good to me. That makes sense, Jordan?
Poor Jordan.
I know. Jordan.
Kind of.
All right, David can explain as I write it down.
Okay.
I get it. I get it.
Cool.
I get exactly what you're saying.
So we've got our unit circle here, right?
Yeah.
I mean, I've got the unit circle pretty much memorized. So it kind of just like makes sense to me. So if I don't make sense, then just tell me, okay?
Yeah, no, I got the first part.
Okay, the first part. So you know how we got this one, right?
Yeah.
Okay, cool. So then what we're doing is we're just moving in increments of 360 degrees because,
It's easiest that way.
yeah, it's easiest that way. That's just how you do it.
You said it. I was like, yeah, that makes sense.
So anyways, we know that if we go around the circle, so pi over 3, if we go around the circle, if we go 3, so this is equal to 180 degrees, right?
Uh-huh.
That makes sense?
Yep.
So basically what it's saying, this is saying that we're going 60 degrees one time, so it put us right here. This is saying we're going 60 degrees twice, which would put us right here. And this would say we're going 60 degrees 3 times, which would put us right here, which is 180, right?
Uh-huh.
So ours is 4 pi thirds, so we know we're going 60 degrees 4 times, which would put us right here, which is 240, right?
Yeah.
Okay, we got 240 degrees here. So we want to go around the circle now, 360 degrees.
Count freaking pi thirds.
So we know that 6 pi thirds is 360 degrees, but we're not at 0, we're at 4 pi thirds. So we just add basically 4 pi thirds onto that, which would give us 10 pi thirds, okay?
Okay, I see what you guys did.
That makes sense. You can convert if
And
it's
then you just do the opposite.
yeah, and then what you could do is you could either do basically this again to go another 360 degrees this way, but I was like, it'll be so much easier just to go 360 degrees the other way from the very first point, 4 pi thirds. So I thought about this one a little bit differently. I said, okay, I want to get here. I'm here, so I need to go 1, 2 backwards. So 2 pi thirds, that's 4, so I just need to make it negative. So now I'm going 2 pi thirds backwards on the unit circle, which will give us this same point right
Same
here,
one.
just the negative version. Does that make sense?
Yeah.
Okay, we're done. That's our group quiz.
Sick. You guys are awesome.
No, you're awesome. You're the one that has to sit there and put up with our talking the whole time.
No, dude, it helps a lot. Just listening.
David's the smart one. Don't get me like.
I know a few small things. That's it.
All right. Okay.
Cool.
We're good to go.
Awesome.
We're done. All right, hey man. So we'll see you next week on Tuesday.
Yeah, that sounds good.
All right.
15.
Sounds good.
Just do you guys want to like just plan basically Tuesday,
Just do
Thursday,
Tuesday,
10:15?
Thursday, 10:15. We only have 4 more meetings.
Yeah, sweet. Almost there, man. And then if anything changes, then we can just let each other know. But otherwise, we can just plan on that.
Yeah.
All
Sound
right.
good?
Yes.
Cool. Catch you later.
Okay.